Hey guys, today we're going to review solving one-step equations using addition and subtraction. Make sure you have these notes in front of you. Make sure your name and date are at the top. You learned about this last year in 6th grade, but right now the thing that's different about it is that we are going to throw some negatives and positives at you. So number one, it says when solving an equation you must first, and we're going to think about this, do what with the variable? The thing we're going to do is isolate the variable. Oh, I don't want that. Isolate. Okay. To isolate the variable means that you need to, do you know what that means? If you think about it last year, every single time you solved a problem like this, when you were solving for the unknown for a variable, your teachers would always say to you, remind you to get the variable by itself. That's what it means to isolate. So get the variable alone or by itself. To isolate the variable, move numbers to the other side of the equation using, and oh boy, I hope that we can remember this. This is what I'm going to say. Sorry, this keeps popping up. Inverse. I want to make it red. We want to use inverse operations. Now, I want you to think back to the beginning of the year. We would say to you over and over and over again, what's the additive inverse? That's kind of what we're talking about right here. So the inverse of a -2 is a +2. The additive inverse of a +8 is a -8. So it's whatever you can add to something or subtract something to make it 0. That's what we're looking for when we say inverse. You must get it to 0. Inverse means opposite. Oh my gosh. I don't know why that keeps popping up. Opposite. Oh gosh. Great if I could spell. The inverse operation of addition is subtraction. And that's in black, sorry. The inverse operation then of subtraction is, of course, please think it to yourself and start writing it. The additive or the inverse operation of subtraction is addition. Write it down, please. Once you find the value of the variable, what do we do to make sure our answer is a solution? We check. Now, you're going to hear us say over and over again, did you check? Did you check? Did you check? There's a reason we're saying it, and it's not just because we want you to do extra work. We really don't want you to do extra work. We want you to learn how to check yourself so that at the end of a problem you can say, oh yeah, that makes sense. I know it's correct. That's why we ask you to check. What states that when you add the same number to each side of an equation, the two sides remain equal? What is that states that? Think for 1 second. Ooh. Okay, I wanted to move that up. I don't know that you've ever heard of this or not, so I'm going to write it in for you right now, but the addition property of equity, and I'm going to type that out, the addition property of equity states that when you add the same number to each side of an equation, both sides remain equal, of course. So for example, I'm going to keep typing here. I'm sure you appreciate that more than my handwriting on this thing. So A plus B equals A plus B. In other words, if I add something on the left side and I add it to the right, it remains equal on both sides. Here's another example, though, the subtraction property of equity. Subtraction property of equity states that when you subtract the same number to each side in an equation, the two sides remain equal. We have to remember these things because it's going to help us solve equations. And our algebraic expression is, oh gosh, that silly keyboard every time. A minus B equals A minus B. So in other words, if I subtract a B on the left, I have to subtract a B on the right. And I'm sure that that will ring a bell as we do some practice problems. I'm going to click on my writing utensils now instead of the text. I want you to think back. I'm going to actually write something off to the side here. Last year in 6th grade, you would have had no trouble solving x plus 12 equals 17. I'm using this as an example because I want you to just connect to what's up here. And actually, let's erase this, sorry. Let's make this x minus 12 equals 17. From what we learned up above, I know I need to isolate the variable. I need to get x alone. The only way I can get x alone is by removing somehow this negative 12. How do you remove a negative 12? Well, by doing the opposite. You don't have to write this on your notes. I just want you to pay attention to this for now. The opposite of negative 12 is positive 12. So if I add 12 here, my addition property of equity says, well, I must add it to the other side, and that way my equation remains balanced or equal on both sides. And now I'm left with x equals, oh, in this case, 29. Okay. Now, if I did a check, do not write this because we have to go back and learn our other way. But if I have 29 minus 12, it should be 17, which was our original equation. Now I'm going to go back and erase all this. So make sure you have the above definitions first. Okay. And let me scroll down while I've got this. Now we're going to try the 7th grade method. Oh, sorry, I went up too far. In 7th grade, now you're doing the same problems, but notice this guy. Oh, yeah. Now we've got some negatives and positives. So we're going to solve it the same way you did in 6th grade, but this time when I add my 12 to both sides, we have to also remember our integer rules. So when I add 12 here, I need to ask myself, wait a second, you know the rules here. Are the signs the same or different? Well, it looks to me like I have a negative 17 and I have a positive 12. Signs are different. I have to find the, come on guys, say it, the difference. Yes. The difference between 17 and 12 is 5. There are more negatives than positives, so it's a negative 5. And on this side, negative 12 and positive 12 become 0 because those are inverse operations. And all that I'm left with is x. So my answer for this problem should be x equals negative 5. Now I want to show you this. When we do a check, we rewrite the original equation. X minus 12 equals negative 17. Okay, now I know now that the x value that we found here is negative 5. So negative 5 minus 12 equals 17. Okay, I have to address something here. So many of my students in the past have gotten to this point and they say, yep, that checks. They don't even actually check the problem. The reason you're doing the check isn't to show us the check. We don't care. We know what the right answer is. The check is for you to see if you did it correctly. Well, the signs here are the same. So we find the sum. The sum of 5 and 12 is 17. Both of the signs are the same, so we keep the sign. Does 17 equal negative 17? It most certainly does. It did check. Let's try this last problem here. I have 1/4 plus x equals negative 2/3. Okay, you're seeing fractions and you're probably freaking out a little bit, but this isn't a hard problem. I still need to isolate this variable. I need to get this x alone. I have a positive 1/4. What do I have to do to 1/4 to make it 0? I just simply take it away. I subtract it. Well, if I do that to the left side, I have to do it to the right side also. So if I have negative 2/3 and I'm now subtracting 1/4, I'm hoping you remember that when we work with fractions, we need to find a common denominator. So I'm going to rewrite both of these fractions with a common denominator. And I get a 12 at the bottom. That's my new common denominator. 3 would have to be multiplied by 4. So guess what the 2 is multiplied by? You got it, 8. And this was a negative, remember. 4 was multiplied by 3, so I have to multiply the 1 by 3. This is also a negative, and I get a negative 3. The signs here are both negative, so I'm going to end up with negative 11/12. Oh, I'm going over my time limit here. How does that always happen? Okay, so if I have 1/4 plus x equals negative 2/3. I have 1/4 plus negative 11/12 equals negative 2/3. Don't you dare put a check mark here without actually doing it. Now I know I can't add 4 and 12 because our denominators have to be the same. You can't add unlike terms. So I'm going to make 4 a 12. I make 4 a 12 by multiplying it by 3. That means I have to multiply the numerator by 3. That's a 3. Okay. Now in this case, okay, I'm almost done. The signs are actually different, and this double sign here can be written as a negative because this is a plus and a minus. So I really have 3 minus 11. 3 minus 11 would be negative 8, and that looks like negative 8/12. Well, if I divide 8 by 4, and if I divide 12 by 4, oh, that's kind of messy, I should get negative 2/3. That means we did it correctly. Please don't lose these notes, and please make sure you submit them through the video. Thank you. I can't get this off. Ridiculous.